ASTM C31, Standard Practice for Making and Curing Concrete Test Specimens in the Field.
Making and curing test specimens is as critical in the process as all the other procedures. Without the proper fabrication and curing of test specimens, all the other testing of the plastic concrete may be considered invalid. Specimens subject to extreme temperature variances or vibrations or left to dry out will be vulnerable to failure, which may lead to costly retesting and loss of production and potential loss of credibility. Be prepared to store specimens properly, which may include the possibility of an on-site curing box if deemed necessary. It is important to know the difference between field curing and standard curing. Field curing is required when determining if a structure is capable of being put in service or for form or shore removal. Field curing is accomplished by protecting all the surfaces of the specimens from the elements in as near as possible the same way as the formed work. Store the specimens in or on the structure under the same temperature and moisture environment as the structural work. When testing to determine if the structure is capable of being put into service, specimens shall be removed from the molds and tested at the time of the removal of the formwork. Standard curing. Standard curing is required when determining if the concrete meets the acceptance criteria. Standard curing requires the specimens to be stored for a maximum of 48 hours in a range of 60 to 80 degrees Fahrenheit and free of moisture loss and vibration. If the concrete is specified to be 6,000 psi or higher, the temperature range is narrowed to 68 to 78 degrees. The procedures for the standard are as follows.
1. Use a small tool to place concrete in the mold. Use care to distribute the material evenly around the perimeter of the mold. 2. For the first layer, fill the mold with the appropriate quantity of concrete. Then, rod the layer 25 times throughout its depth. Distribute the roddings uniformly over the cross-section of the mold. Lightly tap the outside of the mold 10 to 15 times with the mallet, or open hand if using light-gauge single-use mold, to close the voids left by the tamping rod. 3. For the second layer, fill the mold with the appropriate quantity of concrete. This will fill a 4 by 8 inch mold, or approximately 2/3 the volume for a 6 by 12 inch mold. Then rod the layer 25 times. Penetrate the layer beneath approximately 1 inch or 25 millimeters. Distribute the roddings uniformly over the cross-section of the mold. Lightly tap the outside of the mold 10 to 15 times with the mallet, or open hand if using light-gauge single-use mold, to close the voids left by the tamping rod. When 4 by 8 inch cylinders are used, skip step 4 and proceed with step 5. When 6 by 12 inch cylinders are used, proceed with step 4. Step 4. For the third layer, add an amount of concrete that will fill the mold after consolidation. Then rod the layer 25 times. Penetrate the layer beneath approximately 1 inch or 25 millimeters. Distribute the roddings uniformly over the cross-section of the mold. Lightly tap the outside of the mold 10 to 15 times with the mallet, or open hand if using light-gauge single-use mold, to close the voids left by the tamping rod. 5. Adjust the concrete level of underfilled and overfilled molds if necessary. 6. Strike off any excess concrete with the tamping rod, or with a wood float or trowel, if appropriate, to produce a flat, even surface. 7. Verify that the specimen mold has been marked to identify the concrete it represents. 8. Immediately after finishing, provide protection to prevent sample moisture loss, and move the specimens to an initial curing place for storage.